Okay, so welcome back to another video. So today's a definite integral where everything we have inside our integral it's a nested radicals, but inside is we have our base of x and then the natural log. So we have a combination of everything from a nested radicals perspective. So we have x times the square root of x to the power ln of x multiplied by the cube root of x to the power ln square of x to the fourth root of x to the power ln cube of x, and then to the fifth root, so on and so forth. So infinitely nested. So this can actually be done, and actually it's going to be a short video, so it's actually not as hard than it looks from a glance, because what you can do is that you can actually convert everything from x of those bases into a e to the power ln of x with that definition of the, the exponential value. So putting that together, we can actually just substitute that, and then we can actually just simplify everything from there. Then utilizing that idea with nested radicals, infinitely nested radicals, we can use, the properties of exponents to combine everything back together. And then we have something that's actually in a nice little series that it's a well-known series that we'll be utilizing to plug in that value. And then the definite integral itself will actually, after all that, will be easy to simplify. So all that needs to be said. So why don't we actually just jump right in? So let's put everything back together. So the integral from 0 to 2. So inside x, I'm going to write as e to the power ln of x. And then over here is going to be, so e to the ln square of x. I'll put back the radicals back in a sec. I just want to put this just so, it's in terms of looking nice. So then e to the power ln cube of x, that's from over here. And then so now one more, so e to the ln of, e to the power ln of 4 of x. To the fourth power ln of x. That's kind of hard to say. Okay, so with that, so that just go on so forth. So that means put this back here, then here, and then here. Okay, and so that means that's squared. This is going to be a cube over here. This is going to be a fourth root, and then over here, this is going to be the fifth root over here. That just continues on forever and ever. And then with dx. Okay, so after all that, so now we have our new integral. So it's going to be from 0 to 2. So all those nested radicals, I'll convert that back into an exponent form, a rational number. So what we have is going to be e to the power ln of x, and then now we multiply over here. So this is going to be so ln square of x, and then so square. So in other words, I can write that as the same thing as 2 factorial, since it's going to be nested radical, because you're taking inside as you're going deeper into the rest nested radicals. So e and then ln square of x divided by 2 factorial. Then next over here is going to be e to the power, so ln cube of x. And then over here, this is going to be the cube root, and then inside that's the square root, so 3 times 2. So in other words, I can still write that as 3 factorial, in other words. And so next over here is e to the ln of the fourth of x, so that means over here. And then again, fourth root, third root, and then square root, so that means 4 times 3 times 2 under that denominator. So again, I can still write that as 4 factorial. And then the multiplication just go on and so forth. So again, you understand the picture how this works. So putting that now we can actually put everything under to just a single base. So it's going to be 0 to 2, and then e to the power ln of x. So everything here shares the same base, so now I can just add everything together. So plus then ln square of x divided by 2 factorial plus ln cube of 3 divided by 3 factorial, and then plus the fourth of ln of x, and then divided by 4 factorial. And then the addition just keeps on going on so forth. Okay, so a nice little thing we can do, and this is actually just in case if you want to, this is more in the sense that if you don't know how to, observe what the series looks like, but to make things a little bit into easier perspective. So why don't I actually add and subtract 1 over here? So I'm taking one step further ahead and then actually just factor out the -1 from that. So I have e to the -1 and then multiply by e to the power 1 plus ln of x, and then add this with ln square of x divided by 2 factorial plus ln cube of x divided by 3 factorial, and then so on and so forth, then dx. Another thing is that I can actually just factor out the e to the -1 outside. That's just a constant. So 0 to 2. And then over here is that our exponent is actually in a nice series written as the infinite sum at n is equal to 0 of ln of x quantity to the power n divided by n factorial, and then dx. So then a little side note, we know that specifically for the exponential function, e to the power x for all real x is going to equal to the infinite sum at n is equals 0 of x to the power n, and then we need the parentheses for that, and then all that being divided by n factorial. So that means x for any real, so that means I'll just substitute the ln of x back into over here. So basically what we have is going to be e to the power -1, and then the integral from 0 to 2 of e to the power ln of x and dx. Of course, that's simply, we know that e to the ln of x is just going to be just x. So e to the -1 divided with the times the integral from 0 to 2 of e to the power x and dx. Standard antiderivative, that's easy to find. That's just going to be the same function itself. So e to the -1 and then multiply by e to the power x and then put that back together. I have e to the x and then subtract 1. Then we can evaluate our bounds from 0 to 2. Then we know that if I just plug in that, that means we have just e to the power 1 and then 0 minus 1, so that's -1, so minus e to the -1. Now you can stop there if you want, but we can actually simplify things even further. We can actually note that, well, I'll put the note over here. We know that the hyperbolic function for sine of x, the hyperbolic sine of x, is equal to e to the power x minus e to the -x divided by 2. So simplified this, we have that this is going to be 2 times, and then e to the power 1 minus e to the -1 divided by 2. In other words, that can be written as the same thing, and that is our final answer, that this whole nested radicals of the natural logs is going to equal to 2 times the hyperbolic sine evaluated at 1. So therefore, it sums up very quickly that we have our final value over here in this box, that we actually just utilize, the standard, the easy trick to, well, not really easy, but it's just more like you have to observe carefully on how, nested radicals work, that you can actually write it in a form like this, which just reduces down to the following with utilizing the Taylor series, and then it comes down to just an easy standard definite integral that's easy to evaluate, and then just plug in the values, and we have our answer just like that. So yeah, that's pretty cool if you ask me.